So hello, I'm Timothée. I work at Starkware as a part of the exploration team. I'm currently leading a project named Madara, which is an alternative implementation of the Starknet sequencer. It's an open source project. You can come and contribute, and we will pay you to do so on a PR basis. But today I'm here to talk about Cairo, the language, which has been developed by Starkware in order to easily develop Stark constraints so you can prove any language. So this is Cairo. It's a Turing complete language. So you will be able to write any code you want and then have a proof of this execution. But before, we are going to talk about Stark a little bit. So Stark are mathematical constraints that allow you to prove some execution of computation. So the big idea is if you give me a program and an input, I will be able to give you an output and a proof of this execution, so you can verify that the output is correct given the input using the proof. So that's what the Starkware team came up with, and they created in this paper. They presented it. And in the early age of the company, they were writing those Stark constraints by hand for some clients, like DYDX, which is like a trading platform that was able to build its application with Stark and have like insane performance and no cost for user to emit trade because they can scale very much. So the good thing when you write those by hand is that you learn a lot. The bad thing is not scalable at all, and you have for every new type of operation you want to develop in your application, have to write the constraint yourself. It's really error-prone. It doesn't scale. So they came up with a way to automatize this, which is the Cairo architecture. It has been published in this paper 3 years ago, and it describes a CPU architecture because basically it defines a bunch of registers and memory zone and a set of instructions you can use to write to those memory zone and update the registers. And the big idea is that rather than writing the constraint for your specific program, they wrote the constraint for the virtual machine and the way it's going to update its own state. So by doing so, we can execute any program in this virtual machine and prove its execution by proving each one of the execution steps. So we are not really proving your program, we are proving the execution of your program on this specific virtual machine. Good thing with the design of the Cairo virtual machine and the language itself is it allows for non-deterministic computation. The idea is that when you write Stark, you don't really write instruction, you write constraints, and then there will still be instructions, they will be executed by the prover, but the idea is that the prover can execute actually whatever code he wants as long as it respects the set of constraints you define. So we are going to approach this with an example. Let's say you want to find the square root of this number, which is 31. You can go two ways. You can go the classic execution way, where you will create a function that will compute the square root of a number. It's a fairly complicated thing in terms of execution. You have to find it progressively. Or you can go the non-deterministic way, which is the second example. The idea is that if you were able to magically guess that the value you are looking for is 31, you can then write a constraint that will take this value, multiply it by itself, and assert that it was equal to the original value you were looking the square root of. And this, in terms of proof, just get the job done, and you don't have to prove every execution of your square root computation algorithm. So you can spare a lot of computation doing this, and it's done in Cairo with what we call hints, which is what is happening in, let's use the laser here. So this part of the code between the weird brackets, it's something you give to the prover to execute, and it can be any piece of computation. It can be Python code, Rust code, C code. It can do HTTP request. It can do whatever we want. The important thing is that at the end, it updates this value into the Cairo code. It sets X to this value. And then, as a developer, you have to write the correct constraint to make sure that this value is the one you were looking for and is valid in the context of your execution. So the first way you can do this is with a syntax like this. So this is a kind of, it looks like assembly, and it is assembly for the Cairo virtual machine. You can see some AP, some FP. Those are different, those are the two registers that exist in the Cairo virtual machine, and you can update them manually, you can call, you can do some jumps when you define label. So the syntax is really assembly-like. The good thing with it is that there is no overhead, and you know exactly what you are doing. The bad thing with this is that there is no abstraction at all, and you have to know precisely what you want to do. So it gets the job done when you have a deep understanding of the Cairo virtual machine, but it's not for everybody to use because there is probably a good learning curve. The good solution is, the good news is that we have a solution. The Cairo virtual machine take as an input this kind of file, which are like JSON-like file. It's Cairo assembly, and any language, in theory, well, if you have the right compiler, can be compiled to this, or at least you can write different language that can compile to this. You declare function, constant, a bunch of things, and then the Cairo VM takes this as an input and is able to execute the contract. So we were able to come up with a higher level syntax, which looked like this and was known as Cairo. Now it's known as Cairo 0 because we come up with the next thing on this talk, which is Cairo 1. And the thing is, people at Starkware, they are mostly mathematicians and cryptographers, so they really liked Python, and they kept the Python syntax, so you can recognize it. It gets the job done when it's about looking like a regular language. It looks like Python, but when you write with it, there is still a lot of caveats that you have to deal with. Basically, when you are doing if-else, you will get problem because the compiler doesn't know by how much you have moved the register, the AP pointer, in each of the different arms. So you have to add additional code in order to say to the compilers that it's not aligned. So there is a lot of things that has been abstracted, but not enough, and you still have to understand and to care about what's underneath. So it was quite a good intermediate level of abstraction, but we wanted to go further to give people a really easy to use experience when writing Cairo code, but especially smart contract on Starknet. So that's the current syntax. It's now inspired by Rust, and that will be like what we are going to talk on this talk. I will go rapidly over like the syntax of the language. To do so, I will be using a lot of examples from the Cairo book. I think if you are interested, you should give it a look. It has been written by developers in the community. It's open source. You can contribute to it if you want. It's a nice resource. So one thing with the Cairo VM is that the memory is immutable. It's required in order to be able to prove the execution. Once a value in memory is set, you cannot update it. But with Cairo 1, we give you like the abstraction that allow you to write code that feel mutable, even if it's actually not mutable. And a lot of things that have been developed and went into the architecture of Cairo 1 is about abstracting a lot over the virtual machine to give you a developer experience that feel like what you may be used to, but actually there is a lot of abstraction on top of this. Same thing, on the Cairo virtual machine, there is only one single type, which is the felt, the field element, but it's not really handy, so we come up with different types. You have the scalars, you have your bools, you are able to build structure, custom types, and you even have enums. You can use those enums in the control flow to do some matches. You still have the if, else, but no, there is no this weird thing about the revocated references I told you about, which existed in the previous version of the language. And we now have loops, which is also a great improvement, because in Cairo 0 there was no loop, only recursion, which make it a bit specific to write. We also have generic for struct, for function, for trait also, because there is trait in the language. And there is a few default collection. The first one is an array, so it looks like a vector, but it's actually not one. Because of the non-mutable memory, we have to put some limitations, so you can only do two things with it. It's happen at the end or pop from the front, but you cannot change values in the middle or do anything else. You can read it. So if you want data structure with mutable memories that feel mutable, you have to go with dictionaries. So it's not a dictionary at all if you look at what it does behind the scene, but it has the API of a dictionary. When you write code with it, you are able to define a key and give it a value and then later update this value. So it's feel good to use. We also implemented ownership because we are a big fan of Rust now. So each value is only owned by a variable. When this variable goes out of scope, the value is dropped, and you can pass values by reference to functions, so you don't have to return the ownership out of the function each time. And there is this really specific thing, which is like Cairo only, which is snapshot. It allows you to create a view, a snapshot of a value of a connection at a specific point during the execution of your program. So you will create this snapshot, then you can continue to change your value or like add element to your array, but the snapshot will not change at all, and you are able to pass it to functions that require non-mutable access to this kind of type. And it's really useful. It solves a lot of limitation of the language. And then you have Starknet, which is kind of a superset for Cairo. It had a ton of features that are related to writing smart contracts. So you have new libs, new macro, all these kind of things. But it will be, I think, the next step in your discovering of the language. And that's it for my talk. I will add I still have some time, so I will add a few more ideas. So as we've seen, because you can compile different type of language to the Cairo VM, you can have different language with different trade-off. We saw that in the history of Cairo so far, we traded the fine-grained access that you have to the virtual machine against a lot of abstraction. It's important to mention that in Cairo 1, you also lost the ability to do hints, so you cannot do non-deterministic execution anymore. You can do it with a set of whitelisted syscall that that contain non-deterministic execution, but you cannot add your own anymore. So this is really nice for Starknet, because we don't want users to be able to upload like any execution they wish onto the blockchain, onto our servers. But for computations that you want to do off-chain with your own prover, it may not be the best trade. You maybe want to be able to write some non-deterministic execution, and so far you will have to keep using Cairo 0 to do so. But I think in the future we may see like other language pop off that propose a different mix of those trade-offs between abstraction and fine-grained control over the virtual machine. And yeah, so that's my guess for the future. Is there any question? We still have 8 minutes.
Hi. I have a question regarding the Cairo 0 and the Cairo 1. And then as a Cairo 0, as a low language, we know that there is a now Cairo 1, right? And the more expressive language addition with the Sierra. And then what is the kind of like defining factors that separates those two languages? Like, let's say if the Cairo VM extends its use cases beyond Starknet, maybe in Cosmos, maybe in Polkadot, and how does it mean for the application builders on those ecosystems that see in those two?
Question is, what's the defining factor between Cairo 0 and Cairo 1?
Yep.
Yeah. Mm-hmm. So the huge thing with Cairo 1 that justifies its development is that you cannot write code that is not provable. With Cairo 0, if you write code and there is an assertion that fails, it will panic and you won't be able to generate any proof for this execution, which is a problem in the context of Starknet, because we want to be able to charge users that send transactions that we fail. And if we cannot prove a failed transaction, we cannot charge them for this. So in Cairo 1, we introduce an intermediate representation during the compilation, which is Sierra, and that main purpose is to make sure that everything that compiled to Sierra will result into a provable execution of the Cairo virtual machine. So that's the main difference, and then it's trade-off in terms of abstraction. So you will sacrifice a bit of performance, you will have some overhead, in comparison to Cairo 0 and to Cairo assembly specifically.
All right, thank you.
So suppose that I want to prove computations in Rust. So I will have to write a compiler, right, from Rust to Cairo. 1, and 2, would I have a guarantee that it will give proofs for any computations in Rust?
What's the second question? A guarantee that?
So once I have a compiler from Rust to Cairo, then the second question is, does that guarantee that I can generate proofs for any Rust computations?
Well, I'm not sure you can. We tried a little bit this way internally to be able to directly write code in another language and prove this computation. And we gave up on this. Rather, we went with the creation of language that are much more limited and that allow you to write code that makes sense from the point of view of the Cairo virtual machine. Because when you write Rust, there is a ton of things that make sense only in the architecture, in the context of the x86 architecture or classical computer like this. Here we have like a specific hardware. Even if it's a virtual machine, it could be like its own processor at some point, and it only have 2 registers, different memory zones. Like it's really different in its nature, in the constraints. The memory is non-mutable. So I guess we could imagine some kind of library framework that you can write in Rust and that will abstract that part, but it's basically making a language library in Rust. So
but
far,
since it is Turing complete, right? I should be able to convert any program in any language to Cairo.
Well, I'm not sure.
In theory.
Maybe, but I have no idea.
Thank you. Possible to work with variable-sized loops, for example. I don't know the exact number of structs I want to process. In one case, I need to create 10 structs, in other 20 structs, etc. With loops with variable length, yeah, it's a problem, for example, for CIRCOM.
Sorry, I don't get the question. It's
is it possible to write a program who runs a loop over a pack of structures, but the size of this loop depends on the previous computation?
Oh, so the way you pass like input to the program is through hint, non-deterministic computation. So you will create like a variable, and then with some non-deterministic computation, you will read your desired input from the local file system or the command line, and you will put it into the Cairo execution environment. So yeah, you can pass arguments that are any size you want.
Okay, thank you.
You're welcome. Are we good? No more questions?